Hi, in this video we are going to work on inverse trigonometric ratios. Basically, as the name suggests, we do the inverse of what we do with trigonometric ratios. For example, let's say the angle C is 34 degrees and BC is 6 centimeters. If we want to find AB, then all I have to do is, after finding out which is opposite, which is adjacent, which is hypotenuse is this one because it's across the 90-degree angle, I'm going to choose the trigonometric ratio that I'm going to be using, which will be the tangent ratio. So it's going to be tangent of 34 degrees equals x, the opposite side, over 6. And I'm going to end up with 4.05 up to 3 significant figures. So these are the trigonometric ratios that we know. We are calculating the side length by the help of the angle. So the inverse will be such that we are going to find the angle by the help of the side lengths. So for example, we are asked to find the size of CAB, this angle, given AC, which is the hypotenuse, it's 8.2 centimeters, and BC, one of the right sides, 5.8 centimeters. And across this angle is the opposite side. So basically it's opposite over hypotenuse. So referring to Sohcahtoa, it is going to be sine, right? Because opposite over hypotenuse. So I'm going to write this down. I'm going to say sine of this angle CAB must be 5.8, the opposite, over 8.2, the hypotenuse. This is where I'm going to introduce the inverse trigonometric ratio. So if I go with the angle when I'm using the trigonometric ratio here, right, I'm going to use the inverse trigonometric ratio with this fraction here. So I'm going to write sine inverse of 5.8 over 8.2 must be equal to the angle CAB. So here I substitute the angle size into the trigonometric ratio to find the missing angle, for example this one or that one. And in the inverse trigonometric ratio, I write the ratio of the side lengths into the inverse to find the angle. At this point I'm going to use my calculator, press shift and then sine, so that I'm going to get sine inverse, and then I'm going to press the fraction button to write the fractions, and when I hit equal sign I'm going to get the result. Of course this will be a decimal which you have to round according to what the question gives you, but by default the angles round to 1 decimal place. So this answer will be 45 degrees. Another example. So here PR is given to be 12 and PQ is given to be 17. We are asked to find the size of the angle PRQ. Now, remember that it's always the letter in the middle which is the actual angle. So we are asked to find the size of this angle. Now, the same idea applies. I have to find the names of the side. So according to this angle R, that's going to be opposite, and it makes this angle adjacent. Obviously, across the 90-degree angle is hypotenuse. So I'm given opposite and adjacent, hence I should be using TOA, meaning tangent. So it's going to be the tangent of this angle R, if you'd like, is equal to opposite 17 over adjacent 12. If tangent of R equals 17 over 12, then tangent inverse of 17 over 12 must be equal to the angle R. Now I'm going to calculate it with my calculator. I'm going to press shift and tangent so that I'm going to get tangent inverse, and then I'm going to press the fraction button to write the fraction there, and when I hit equal sign I'm going to get R to be 54.8 up to 1 decimal place. So basically this is it. Once you decide which trigonometric ratio you're using, you're just going to take the inverse of it to be able to find the size of the angle. Now is your turn. Please solve these questions on your book and submit your answers to online self-check. Thanks for watching.